Okay, you're welcome once again to learnwithbonitas.com. Today we'll be looking at mole concept. Mole concept. What is mole? Mole is a unit of measuring a chemical substance. Just like you can measure the mass of a substance in grams, you can measure the volume of a substance in cm cube or in dm cube. You can also measure the amount of elementary entities a chemical substance contained in moles. Mole is the best form of measuring elementary entities because if a substance is gas, it may be difficult to determine the mass or the volume at a different temperature and pressure. So a standard unit of measuring elementary entities was established, and that is mole. So we define mole as the amount of substance present in a given mass of an element. Carbon-12 was used as a standard in the study of mole concept. There are different mole concepts we are going to look at. First is the Avogadro's mole concept. Avogadro's mole concept. In Avogadro's mole concepts, he says that a given mole of a substance contains a certain number of elementary entities. A given mole of a substance. One mole, for example, 1 mole of an atom, according to Avogadro's, what will make a mole of an atom is 6.02 times 10 raised to the power 23 atoms. So this number of elementary entities will make a given mole of an atom. If the element you are measuring is a molecule, 1 mole of a molecule, according to Avogadro's, is going to be equal to 6.02 times 10 raised to the power 23 molecules. If the substance you are measuring is an ion, 1 mole of ion is going to be equal to 6.02 times 10 raised to the power 23 ions. Any particle you are measuring, 1 mole of that particle is equal to 6.02 times 10 raised to the power 23 particles of that substance. If the particle is an atom, or the particle could be molecules, it could be ions. So we call this mole concept Avogadro's mole concept. He sees a mole as a cup of rice, a cup of beans, or a cup of corn, and they must contain the same number of particles. So if a cup of rice is a mole of rice, so the number of particles it contains, according to Avogadro, is 6.02 times 10 raised to the power 23 particles of the substance you are measuring. This is the Avogadro's mole concept. So what it implies is that when we want to know the number of moles, if 1 mole is equal to Avogadro's number, the Avogadro's number Na is 6.02 times 10 raised to the power 23 atoms. So if 1 mole is equal to Avogadro's number, what number of mole will give us a given particles? Will give us a given particles. If you do the cross multiplication, you will see that the number of mole in a given substance will be equal to given particles all over Avogadro's number by cross multiplication. Number of mole times Na will be number of mole times Na. 1 times this is a given particle. We divide, right, to get Na. So number of mole is given particles over the Avogadro's number. That means number of mole of an atom, number of mole of an atom will be equal to given particles of the atoms over Avogadro's number. That is Avogadro's mole concept. So the next mole concept we are going to be looking at is mass mole concept. Mass mole concept. In a mass mole concept, we are looking at the relationship between a mass of a substance and a given mole of a substance. In the definition of mole, we say is the amount of elementary entities present in a given mass. Carbon-12 was used in a given mass of carbon-12. And carbon-12, the atomic mass of carbon is 12. So what it implies is that 1 mole of a substance is equal to its atomic mass. 1 mole of a substance is equal to its atomic mass. If the substance is an atom, for example, if I have a sodium, carbon, sodium is 23, atomic mass of sodium is 23, atomic mass of carbon is 12. Carbon was the standard element used in the measurement of moles of an atom. So if I have carbon 12, 1 mole of carbon 12, 1 mole of carbon has a mass of 12, the atomic mass of 12. Remember, I told you that when you talk about atomic mass, when you say that carbon has atomic mass of 12, it does not mean that when you get an atom of carbon and weigh it, it's going to give you 12 grams. No. If atomic mass of carbon is 12, remember that it simply means that carbon is 12 times heavier than hydrogen atom, which has the lightest mass. Okay, so according to mass mole concept here, now it means that 1 mole of carbon or 1 mole of an atom will be equal to its atomic mass. Will be equal to its atomic mass or relative atomic mass. What if the substance is a molecule? It will be 1 mole of an atom equal to its molecular mass. Okay, we're going to see that. So what number of mole is here? Number of mole will give us a given mass of a substance. A given mass of a substance. If we do cross multiply, what will be the number of mole? The number of mole will be what? The number of mole will be given mass, is it not, over what? Over relative atomic mass, or the atomic mass of the atom. So number of mole is also given mass over relative atomic mass. If, for example, the element is a hydrogen atom, hydrogen atom does not exist in one atomic form. It exists in 2 forms. That is diatomic. We call it a molecule of hydrogen. And you know that atomic mass of hydrogen is 1. But here, what you are going to calculate is not the atomic mass, but the molecular mass, which is 1 times 2, 2. If you have oxygen, The atomic mass of oxygen is 16, but here, what mass we'll be looking at is not atomic mass, it's a molecule. It exists independently in two atomic form, what we call the diatomic form. So the mass here is 16 times 2. 16 is the atomic mass of oxygen times 2, which is 32. That becomes the relative molecular mass, or the molecular mass of oxygen. So 1 mole of a substance, if the element is a molecule, 1 mole of a molecule is equal to its molecular mass, molecular mass, or relative molecular mass, molecular mass. You use the word relative when you're talking about the isotopic masses of the molecule or the atom, as the case may be. I know you understand that. So 1 mole of a molecule is equal to molecular mass. What number of mole will give us a given mass? So you can also see that you can say that number of mole is equal to given mass over molecular mass. This molecular mass can be written as relative molecular mass, RMM. So this is the mass mole concept. So number of mole can be a given mass over relative atomic mass, or a given mass over relative molecular mass. If the substance is a compound, let's say sodium hydroxide, the mass of this compound is called a molar mass, right? It's called a molar mass. And the molar mass of this compound is 23, which is the mass of sodium plus 16 plus 1. The sum of the atomic mass of a substance gives us the molar mass of the substance. So if it's a compound that is given, it means that 1 mole will be equal to molar mass. 1 mole will be equal to molar mass. What number of mole will give us a given mass? You will see that if you cross multiply, you will now still have that number of mole is given mass over molar mass. Given mass over molar mass. Okay, we have to look at volume mole concept. This is often used when the substance measured, or you want to determine its mole, is a gas. We often use the volume concept to determine the number of the mole of a gas. By studies, at a standard temperature and pressure, 1 mole of a gas is equal to 22.4 dm cube. We call this gas molar volume. 1 mole of a gas, 1 mole of any given gas at standard temperature and pressure is equal to 22.4 dm cube. We call this gas molar volume. So at standard temperature and pressure, a given mole of a gas is equal to 22.4 dm cube. That is gas molar volume of the gas. Now, 22.4 dm cube is the same as 22,400 cm cube. You multiply by 1,000 if you are working on cm cube, because 1 dm cube of a substance is equal to 1,000 cm cube of the same substance. dm cube is the same as a liter. 1 mole of a gas is the same as 22.4 liter of the gas. Okay. Now, what number of mole is going to give us a given volume of a gas? So the number of mole can be determined as the given volume, the volume of the gas which is given, over gas molar volume over 22.4 dm cube, which we call gas molar volume. Gas molar volume. So these are the mole concepts. We are going to use this concept to do calculations, to do some calculations, as we are going to see in the next video.